Why is Uranus tilted almost sideways? In the solar system, Uranus is the only planet that rotates with a tilt of up to 98 degrees, a bizarre phenomenon unseen in other planets. What makes it so different? Let's explore fascinating scientific theories about a massive collision, early gravitational influences, and the unique consequences of this extreme tilt. If you love exploring the universe, don't forget to like, share, and subscribe to the Space Explorers channel so you won't miss our upcoming exciting videos. Uranus is the seventh planet from the Sun in the solar system and belongs to the group of gas giants, along with Jupiter, Saturn, and Neptune. However, what sets Uranus apart from the other planets is its extremely tilted axis of rotation, about 97.77 degrees relative to the perpendicular to its orbital plane. In other words, this planet is almost lying on its side as it orbits the Sun, as if it were rolling rather than spinning upright like Earth or Jupiter. This phenomenon is not only a curious aspect of celestial mechanics, but also raises major questions about the formation and evolution of Uranus. Why is Uranus's rotational axis tilted so dramatically? What happened in its past to give it such a unique characteristic? These are the questions that astronomers have been investigating for decades. 1. The strange consequences of Uranus's 98-degree tilt. Uranus's nearly 98-degree tilt creates a series of highly unique physical and climatic consequences, unlike any other planet in the solar system. A year on Uranus lasts about 84 Earth years. Because the planet is tilted, each of its hemispheres faces directly toward the Sun for 42 years. Meaning there are places on Uranus that experience 42 years of continuous daylight, followed by 42 years of complete darkness. This unusual distribution of sunlight makes the concept of seasons on Uranus completely different. While on Earth, the seasons change every 3 months, on Uranus, each season lasts over 4 decades. Not only that, but the effects of the tilted axis also influence the structure of its magnetic field, the presence of thin dust rings, and the rotational direction of its moons. For example, Uranus's magnetic field is tilted about 59 degrees relative to its axis of rotation, and its magnetic center is not aligned with the planet's core, which is unusual compared to the magnetic fields of Earth or Jupiter. The rings of Uranus, first discovered in 1977, do not lie in the plane of the ecliptic like Saturn's rings, but are tilted along the planet's abnormal axis, causing them to orbit almost perpendicular to the orbital plane. All of these factors suggest that Uranus's tilt is not only a unique feature, but also deeply impacts the overall structure and physical behavior of the planet. 2. The giant impact hypothesis. The most widely accepted explanation. The most widely accepted scientific explanation for Uranus's extreme tilt is that, in the distant past, the planet experienced a violent collision with a massive celestial object. According to estimates from numerical simulations and planetary physics studies, the impactor may have been as large as Earth, or even twice that size. The collision wasn't powerful enough to destroy Uranus, but it had sufficient force to tilt its rotational axis by nearly 98 degrees. Moreover, researchers believe the impact may have disrupted the electrically conductive fluid layer inside Uranus, responsible for generating its magnetic field, causing the field to become both off-center and significantly tilted. Such a massive impact could also have affected the internal heat of the planet, potentially explaining why Uranus is the coldest planet in the solar system, with an average temperature of around -224 degrees Celsius. Simulations from Durham University, UK in 2018 demonstrated that an oblique impact with a large celestial body could realistically account for all of the characteristics we observe today on Uranus, from its extreme axial tilt to its unusual magnetic field structure. 3. Indirect evidence supporting the giant impact hypothesis. Although we cannot see the collision that occurred billions of years ago, indirect evidence from observations and physical modeling strongly supports the plausibility of this hypothesis. First, the orbits of Uranus's major moons, such as Titania, Oberon, and Umbriel, revolve around the planet's tilted equatorial plane rather than the ecliptic plane. This suggests they may have formed after Uranus's axis was already tilted, or that they were reoriented following the impact. Second, Uranus's thin dust rings also orbit along the tilted axis, aligning with the planet's skewed rotation, indicating the ring system was also affected by the tilting event. Additionally, Uranus's unusually cold temperature, colder than Neptune despite being closer to the Sun, may be a result of the impact, which could have caused the planet to lose a significant portion of its internal heat. All of these details, from the moons and rings to the magnetic field and temperature, collectively strengthen the credibility of the giant impact hypothesis. Another hypothesis suggests that complex gravitational influences from other giant planets in the solar system, particularly Jupiter and Saturn, may have caused orbital resonances that altered Uranus's angular momentum over time. Some scientists have even speculated that Uranus once had a much larger moon, and gravitational interactions, or the moon's eventual fall into the planet, could have shifted its rotation axis. However, these alternative hypotheses still have significant shortcomings. They do not yet provide a clear explanation for the planet's unusually offset magnetic field, its satellite system orbiting along the tilted equator, or its extremely low temperatures, all of which are more comprehensively accounted for by the giant impact hypothesis. 5. Why doesn't science have a definitive answer yet? One reason the question "why is Uranus tilted?" still lacks a definitive answer is that we know very little about Uranus itself. To date, NASA's Voyager 2 is the only spacecraft to have flown past Uranus, and that flyby occurred in 1986, lasting only a few hours. The limited data collected during that brief encounter is not sufficient to fully understand the planet's internal structure, detailed magnetic field, or the interaction between its atmosphere and core. To obtain a precise answer, scientists need a dedicated orbital mission to Uranus, similar to the Cassini mission for Saturn. NASA and the European Space Agency, ESA, are currently considering launching a Uranus probe sometime in the 2030s. Such a mission could measure the magnetic field, map the planet's internal structure, track satellite movements, and perhaps even uncover traces of past events such as a giant impact. The phenomenon of Uranus's nearly 98-degree axial tilt remains one of the greatest mysteries in planetary astronomy. While the giant impact hypothesis is the most widely accepted explanation, it still represents only a fragment of an incomplete picture. Fully understanding the reason behind this extreme tilt would not only unlock the secrets of Uranus itself, but also provide deeper insight into the formation and evolution of gas giants across the solar system. In the future, as technology allows us to explore Uranus more closely, the question "why is Uranus tilted?" may no longer be a mystery, but instead, a key chapter in the broader story of chaos and creation within our stellar neighborhood.